We're going to solve a logarithm with a variable base and a variable input argument. And so I'm going to model it after just this concrete example. Let's say log base 3. And no need to write 3 parenthetically here. So let's say log base 3, and I will write the input argument parenthetically, even though a lot of people leave that out. So log base 3 of 81 is equal to 4. That's tantamount to saying 3 to the 4th is equal to 81. So for every logarithmic statement, there's a corresponding exponential statement. And so I'll put the just double arrows here to connote equivalence. And what you get is 3 to the 4th. Again, this is a one-to-one function on the right-hand side. It's a one-to-one function on the left-hand side. Every logarithmic statement has a corresponding exponential and conversely. Okay. Now we're going to use that, just this numerical example, to motivate this. Okay. This is exactly corresponds to this numerical example. And so again, the one that you see right here would correspond to the one here because a logarithm is an exponent. Okay. Now, so what this leads to, if you want to solve for x, is minus 1/6 minus 1/6 is equal to x minus x over 7. Now, what is the right-hand side equal to? Well, we have minus 1/6, first of all, still on the left-hand side, is equal to, now this is 7 over 7, so this would be 6x over 7 on the right-hand side. And then let's see what happens here when we simplify everything. This would end up being 7 minus 7 over 36 is what I'm getting, folks. Minus 7 over 36 is equal to x. And I'm just double checking, make sure I did that right. Now, I can hear a lot of people screaming already that you're not allowed to have a negative base. Well, yes, you are. It's just not that the logarithm function might not be continuous, or it might be undefined in a lot of spots. But you can still think of a negative base in this context. All functions aren't required to be continuous or defined at every point. But a lot of people are just taught and they memorize that the base can't be negative. But we did get a negative base here. The base was a negative value. In other words, you can check this if you want to. If you substitute if you substitute our solution in right up here, you'll end up getting a negative value right here. Okay, which is shocking to some, but that's just because they've been taught that you can't do that. But you can have complex complex logarithms with negative bases. All right. And we're not particularly worried about that. We're just worried about finding a solution for this statement right here. So the solution is x equals to, what did I get? Minus 7 over 36. And y'all, again, you can verify that when you put minus 7 over 36 in right here, you actually get the number back. So it's sort of a fixed point for this linear function, I guess. Okay, but again, if you put minus 7 over 36 in here and solve, it ends up being minus 7 over 36 back. But anyway, that is the solution. And to hell with everybody that thinks you can't have a negative base for a logarithm.